Okay, so when we've talked about nice sinusoidal loads, or I guess with transfer functions we introduced impulse loads and step loads. But what if we want something either more complicated, or you just want a more generic system to model it, right? You don't want to have to solve a new equation each time you do it. This is a great piece, a great way to put things into code, so you can automatically solve this. Right? We'll do a Simulink problem like this. You can take any sort of arbitrary loading and apply it to a system. So we can, let's say we have an arbitrary load that looks like this. All right, so we have f of t, and we have a function of t. So the time response of a system to an arbitrary input force in time can be calculated using a series of impulses, right? So this method allows for the practitioner, right, to easily solve and equate the response of any load if you just kind of set all of your impulses into a for loop. This is often more efficient than solving, using direct methods, particularly because you can program it, right? So how do we break this up into an impulse? Well, let's take a delta time. Actually, let's just do it like this, right? So let's say we have time 1. We're going to model that as an impulse. Let's use a different color. How about orange? We have time 1, and that's going to be an impulse f at t1, right? And so this is an impulse we can apply. And then maybe we have another impulse here. And that's T3. And that's F at T, I don't know why I said T3, T2. Then maybe we have another impulse here. And that would be T3. And then we have F at T3. Right? So you can see pretty quickly, if those are the 3 impulse, I can't point the screen. So if those are the 3 impulses that you take, you're going to have a pretty rough approximation of the system, right? So all models are wrong. Some models are useful. I don't even know how useful this model might be for you. But as you solve this for a smaller and smaller delta t, right, as you solve more and more impulses, this can get quite accurate.